Today we're going to see this suspension system that you see on your screen, and what we would like to do is to derive the equations of motion of the suspension system and do a simulation using Simulink. So what we're going to do is derive the equations of motion and then convert those into a Simulink block diagram. Once we have the Simulink block diagram and we get it running, we can change some parameters to study um, how the suspension behaves. Like, for example, you could change the spring or the damper, or you can change the tires, make it stiffer or smoother tires, and see what the suspension is going to do. So let's get started. And here we go, and we have this block diagram in here. Now that we have this nice tools, I could just pick this one in here and draw the first one in there, and then we'll just um, define. So if you move this up this way and x1 like this, it follows that this is going to get an opposition on this side and also an opposition on this side, and of course the mass mg. This would be one. This is just one tire suspension, so it would be 1/4 of the car. This would be a minus k times x1 minus x sub 2. X sub 2 being the displacement of the other mass. This would be b multiplied by x1 dot minus x2 dot like this. So on the other one, on the other mass, we need to do the free body diagram of this, and we'll see it in a moment here. In here we will have that this force is acting on this side, on the other direction will be acting over here, see? So this would be a k times x1 plus x sub 2 like this, and this would be a b times x1 minus x2 dot. Okay, also we know that this is going to pull it down with a force equals to this. We need to put some numbers. This is k sub 1 and b sub 1, and this would be k sub 2. So this would be a minus k sub 2 times x sub 2. So these are the equations of those are the free body diagrams. So what we need to do is to write the differential equations that correspond to each one of them. And so in the first one in here, I will say this is minus k times x1 minus x sub 2 minus b times x1 dot minus x sub 2 dot minus mg. This is equal to m times the acceleration. So m x1 double dot. Okay, this is the second equation. You're gonna have that k times x1 minus x sub 2, and then plus b times okay, now this is minus k sub 2 times x sub 2. So this is going to be equal to the second mass. This would be m1 over here and this is going to be m sub 2. This is going to be m sub 2 times x sub 2 double dot like that. So given these two equations, we can build our block diagram. I have mentioned, and I will say it again, that I prefer that you keep the equations in the summation form in here. You don't need to organize them by order of the variables, but you keep the outputs and you keep the inputs, and everything would, would work here. I mean, it's just, we need to get these two equations in summation form and then define what the inputs and the outputs are. But in this case, I'll just do it from the very first one. One thing we could do is we could try to build this directly in Simulink from here. In other words, and we have been used to first drawing it on paper and then transferring it to Simulink. We could give it a try to do it directly in Simulink and see how it goes. Let's give it a try. So let's just go directly to Simulink and we'll translate these equations into a block diagram. So to do that, we need to run Simulink first, and that is going to go over here. I think we could try this. MATLAB is going to produce MATLAB has Simulink as one of its toolboxes. So at this point, if we want to run Simulink, we will have to enter it in here, and then MATLAB calls this tool, and the same workspace in Simulink is the workspace in MATLAB. Okay, so we need to click on New for a new system. Yeah. And then we need to do the most common blocks. Obviously, we're going to need constant like this. We're going to need two integrations that we have, some gains. Yes, we're going to need a few of these. We need a summation point right here. Okay, why don't we just, with those a few tools and our our equation, we're gonna attempt to do this one, okay? So in here, the first thing we do is to write a summation point and see how many we're gonna have. Okay, so we have 1, 2, 3 terms. All three are negative, so I think it's important here to put that here. Okay, all these three are negative. The first thing is this mg here. I could attach it to this one. Okay, so then we have the result in here, that is the mx1 double dot. If you divide it by m1, you get x1 double dot like this. So if you join two, just click on the first and hold the key is the control key, and it will actually join. See here you have okay. So this is the one that comes from x1 minus x sub 2. This is what x1 minus x2. So we don't have the complete information, so we have set up so that we can build this two in here, but we need the second equation to be able to do that. So what I suggest is we look at the second equation as well and do some drawing in there. Okay. So where my second equation is down here. Oh, okay. Okay, now we're fine. So the second equation has three terms. I need a summation point in here. I guess we could either duplicate this or get new ones in here. Possibly better is to get new ones. So we have the second summation point. We have okay. So how many? We have three terms also. So we need to do this three here. Very good. So in here we have this comes with the derivative, and we're gonna need a control V. We're gonna need to bring others in here, and I think what we want is also a scope in here, so we don't leave things sort of hanging in there. Okay. We need to look at x1 and x2. This one is gotta be x1 and x2. In here, this is x1, but the other one down here, yeah. So this is x2. Okay. So we're gonna need some sort of a summation point to create the difference between those two. In fact, that is in here the case that we may need to invert this. Okay, Control I, like that. All right, so we have to okay, so and then we need to put the value of k in here. See, now that we have the difference between those two, we can make the connections. And then you have another one, xb1 and x1. Okay, so on the second one, we need to create the difference between the, say for this, between the velocities. So we need a summation point over here. We might have to make it a little bigger. Okay, so we have the velocity over here. Somehow it didn't connect very well. Control I, and there we go. So we have the velocities difference, and that too has to go through a gain, which in this case is B. Yeah, gain is B. Okay, so this one in here we have to invert it too. And then we connect it over here. It's getting there. So we got done with the first equation. The second one, x1 minus x sub 2, is this signal right here. So you could potentially go this way here. Yeah, x1 minus x2. Wait a second. I want to make sure that. Okay. We have this. We have this negative, this other negative here. This is perfectly fine. The second one is the one that I need to make sure that these things are positive in here. X1 minus x sub 2. This, the third, is gotta be, is the term on the left hand side, and this is gonna be a plus, the last one. Okay, that is this term. The one for the velocity terms comes from here, and that one is it. And this would be to put this one in here. and then we have M2 x2 M2x2. This is going to be another gain, so this would be like this, and this one is gonna go over to here, and this is going to be x2 from here. Okay, so we have this feedback, and I believe that would be it, because this is x of 2, and then minus x1, x2, that would be, no, plus, this would be this plus. The other one is also plus, so we need to change that. Okay, and then K2, that's a negative one, so then we're gonna go, we're doing good. So in here you have a gain of, this is case of 2. Okay, what is the gain over here? No, we do not have a gain over here. We have a gain just to 1 over m. Okay. One over m. And then we need to do the two integrators, because I don't see that here either. So we have an error in there. So we have to integrate this with this, with it, with this. And then finally this with that. Okay, I think we have it now. We have the differential equations. Those two differential equations that we have up here, this one, and this have been introduced to this block diagram. Okay, so we have all the connections now, and we could do a simulation, but the first thing is to translate these equations into this form, into this graphical form that Simulink does.